Now I'm going to be talking about 11 part C over here. Okay, I will not be going through A and B because I think A and B is quite easy. So what I'll do is I'll go through part C over here. Okay, so without further ado, let me just quickly write down the answer for part A. For part A, right, the sum alpha plus beta will be equals to 3p, and alpha beta is equals to half. Now for part B, the quadratic equation that we have is x squared plus 6px plus 2 equals to 0. Okay, for part B, it's a show question, so you just need to show that your discriminant is equals to 0, because here we are not going to solve the equation. Okay, so here given that m is greater than 0 and n is less than 0, we are supposed to determine the nature of roots of the equation mx squared plus 1 minus 2mn over nx plus m. So once they have some trigger words that they're telling us that we are going to determine the nature, okay, you know that the words on the chapter which you have seen these wordings are from discriminant. So basically, in order to determine the nature of the root, what we can do is we can consider the discriminant. Okay, so you can see that this will be A, this will be B, this will be C, and you can actually produce the discriminant to be B squared minus 4AC. Okay, and that in itself can give you the discriminant. So what will the discriminant look like? That is where we need to try to evaluate this further. Alright, opening up my numerator, a minus b bracket square, this will be a square minus 2ab plus b square. So b square will be 2mn square, so it'll be something like 2mn bracket square, right? Which is also basically 4m square n square. So that I'll write it as 4m square n square, and then over this n over here, I'm going to square it, so it'll be n square. Alright, so over here this is minus 4m square on the right hand side. Now because I really want to try to see if I can put them together in one fraction, what I'm going to do is I'm going to put n square here over n square, so that I can combine my fraction into one. Without further ado, that's what I'll do. I'll combine my n square, 1 minus 4mn plus 4m square n square minus 4m square n square over n square, and you can see that these two terms, they are the same, so I will cancel them off. I am left with 1 minus 4mn over n square. Okay, so this is how the simplified discriminant will look like. But you realize that the question, they did give you something. They actually told you that m is more than 0 and n is less than 0. How does that help you? Okay, this information is actually very useful, because this information will help to determine how your numerator will look like. Now because m is greater than 0 and n is less than 0, okay, based on these two, right, one is positive and one negative, it will tell you that mn is negative. Now it will tell you that if I were to multiply by negative 4 on both sides, it will become positive. Okay, so I'm going to work from this information to work towards my discriminant. Okay, so if I plus 1 to both sides, 1 minus 4mn will definitely be more than 1 from the previous step, because from this information, recap again, because m is positive, n is negative, if the product of 2 will be a negative number, I multiply by negative 4, that will give me a positive number. I add 1 to both sides, that will be even more, it will be greater than 1. Now if I were to divide by n square, you can actually see that it will definitely be positive, because n square is a positive number. Okay, So if it's greater than 1, it has to be greater than 0. So because if it's greater than 1, it has to be greater than 0. So what you can conclude is that this discriminant, right, which is equals to 1 minus 4mn over n square, right, is actually greater than 0. Okay, so this discriminant is actually greater than 0, and this implies that since my discriminant is greater than 0, the equation, right, will have two real and distinct roots. It has two real and distinct roots. Okay, and that is all for this question.